In this video, we're going to talk about sketching parabola and conics. But first, I think it's important that we understand what a parabola and a conic section is. If we talk about the mathematical definition, we're talking about a figure formed by the intersection of a plane and a right circular cone. Now, a parabola is actually a specific form of a conic, a very specific angle, because a conic can be a circle or an ellipse or a parabola. So it's important that we understand these, and I'll talk about that a little bit more after we draw a few of these and kind of understand the definition a little bit better. So first, let's start by drawing a parabola. If we go to our ellipse dropdown, we have parabola as an option. Now, when you're defining a parabola, the first thing you're going to define is actually a central point here. And then the next thing you're going to define is the apex. So you'll notice as we get closer to that central point or that focal point, that the curvature of our parabola changes quite a bit. The farther we get away, the closer to a line this is going to be. And the closer we get to it, the tighter that arc is going to be. So let's just go somewhere out in space. So once you define those 2 points, the next two things you're going to give is a start and an end point. And let's go ahead and do this again from the origin. And this time, let's get in real close, say around 0.13. And then again, start and end point. So you can see these are two very different shapes here, but the important thing is that the curvature the curvature cones are very smooth. The transition is very smooth between these. And this is important when you're talking about creating surfaces, especially complex surfaces. The geometry at the sketch level is very important because if it's bad at the sketch level, it's going to be bad at the surface level. The problem with the parabola, and the parabola has been around for several years in SOLIDWORKS, the problem with the parabola is that it's a very specific example. You don't have a whole lot of control. If we click on this and we take a look at the properties, we really only are controlling the start and end point, this center coordinate, and then this upper coordinate, this apex, this outside point here. As you can see, it's very specific, and it would be very hard for us to define some more complex geometry with that. And that's where the conic comes in. So let's go ahead and start to draw a conic. And the first thing you'll notice is that you have some options here. You can do an auto tangency option. If we're looking at something like these two straight lines, this is where this auto tangency option is great for you. So we start at this bottom line. It's basically our start point. Then we go to this upper line. And then the last thing you need to define is where the row value is going to fall. And this row value is a ratio. And I'll get into that a little bit more. But if you just drag it around some point, then we hit escape, you can see that we've got a very, very nice curve here. Everything's nice and smooth. Now, it's important to note that when we're talking about curvature here, that straight lines don't have any curvature. By definition, there's zero curvature. So blending this into a straight line is going to be fairly impossible because we can't match zero curvature. We're introducing some curvature here. So when we're dealing with surfaces, we're going to avoid straight lines when possible when you're dealing with consumer products and cosmetic type things. But for the context of this example, it's important to note that the curvature combs are extremely smooth. So let's go ahead and turn those off, and let's take a look at creating a conic just out in free space. So we're going to turn this auto tangency off, and we're going to start by just picking random start and end points here. Then we're going to define this upper point, and then we have this kind of central point that we're going to drag around that defines the row value. You can see as you get closer to that other endpoint, it kind of tops out at 0.94. It's actually 0.95 it'll let you go to. And then we go all the way to the bottom, and it's topping out or bottoming out at 0.05. So let's just kind of place this in the middle, and let's talk about what this means. So I'm going to fix these outside 2 points here, and then we're going to select this, and we're going to take a look at the properties. Now, again, we have start and end coordinates, and then we have these upper shoulder coordinates, and then this vertex that they're talking about. And then at the very bottom, we have a row value, and we have a radius of curvature value. And these two are going to go hand in hand. The larger this radius and curvature value gets, the smaller our row value is going to get. That's because this row value is going to be the relation between the two. And let's explain that a little bit more. If we give this guy a distance of 3 inches, and we define our row value as 0.5, let's take a look at the distance between these 2 points here. It's going to be 1.5. And that's because it's exactly 0.5 or 50% of the height of this top point here, this vertex. So if we change this to, let's say, 0.25, it's getting quite a bit smaller. It's going to be 25% of this height. And you can see that the curvature is changing quite a bit. And it's important to note that this ratio has some upper and lower bounds. And as I mentioned, 0.05, this is the extent of what you can do with a conic. So as you can see, this conic has quite a bit of versatility to it. We have quite a host of different ways that we can adjust this curvature. Let's take a look at another file to kind of get a better understanding at what we're doing with these conics and with these parabolas. So when I mentioned that it's a figure that's formed by the intersection of a plane and a right circular cone, we have a right circular cone here, and then I have some split lines. These are going to signify planes. If we take a look at the curvature we've created here, when we're defining this section or this cut, this intersection with a plane, we're actually talking about creating this curve that's the intersection between a plane. As we're looking at this in 2D, we're looking at this from the side now, but if we're looking at this in 2D, we're actually talking about this cutaway here. So the intersection of this plane with a right circular cone. You can see as we get closer to the top, closer to that 0.95 number, that we're actually creating this very tight peak up here, and it's actually a fairly broad curve as it goes out to the outside. But when we're closer out here, we're creating more of this parabola shape, this very broad curve here. So hopefully that gives you a little bit better understanding of what a parabola is and what a conic is, and helps you define these when you're creating your 2D sketches for creating your geometry. So it's very important to remember that you have a few different ways that you can define these. You have parabolas, and then you have these conics, the autotangency option, and then defining these things manually by adding dimensions, adding these rho values and these radius of curvature values. But it's important to understand where this information comes from, what you're defining, and what that means. So hopefully it's a little bit of insight to how that intersection of a plane and a cone is going to create these parabolas and these conics, and gives you a little bit better foundation for creating your geometry in these sketches.